Good morning, all. I'm re-recording these notes because I heard from Cameron that the audio didn't work or barely worked on the first recording. So hopefully this will help and fix that just a little bit. All right, so today we're going to solve nonlinear systems of equations. So basically what that means is we are going to be working with some conic equations. So the equations could be ellipses, parabolas, hyperbolas, or circles. Sometimes they throw in a line with those just to make things a little bit more clear as to what you're actually finding. Okay, so this is just straight algebra. That's all it is. You're just solving a little bit different type of system than you're used to. Okay, so we're still going to use the process of substitution and elimination. And you need to realize that you could have anywhere between 0 and 4 solutions to these systems. So for example, if you had a circle maybe intersecting with a line, you would have 2 solutions, depending on how the line goes. You could have a ellipse, that's lovely, and maybe a line intersecting the ellipse at one point, so there would be 1 solution. You could have a hyperbola with an ellipse maybe that looked like this, where you would have 2 solutions there. You could have a hyperbola like this with maybe a circle in the middle that never intersects, so no solutions. Let's see, one more, maybe you could have an ellipse and a hyperbola like this that you would have 4 solutions. So there's other possibilities, but that's just giving you an idea of what we're actually looking at. All right, so the first problem is, doesn't really matter what kind of conic section it is, but what I see on this one is obviously linear. So this one is going to be, I'm going to use substitution. Usually when one of your equations is linear, it's easier to use substitution than elimination. So if I take this equation and solve it for y, if I move the y to the other side, then I get 3x minus 4 equals y. And then I can use substitution, plug that into the first equation, and solve for x. So let's go ahead and do that. We're going to have x squared minus x. Be careful because you have a subtraction sign in front of y. So safest thing to do is go ahead and put a set of parentheses there. And then the rest of it, minus 1 equals 0. And then inside the parentheses, I'm going to put the 3x minus 4. So number one mistake in all of mathematics is, believe it or not, just basic subtraction. Okay, so now I need to distribute my negative sign. So I get x squared minus x minus 3x plus 4 minus 1 equals 0. It looks like I'm going to be solving a quadratic. So I have x squared. If I put my like terms together, I have minus 4x plus 3 equals 0. So factoring is going to be your friend today. So add to 3 multiplied to negative 4 is going to have to be a negative 3 and a negative 1. So for this one, I'm going to get 2 solutions whenever x is equal to 3 and x is equal to 1. Okay, so now I have to find my values of y that correspond to those x values. So I feel pretty confident that I solved this for y correctly. So now if I go back and use that, I have y equals 3x minus 4. So if I substitute 3 in for x, I get y equals 9 minus 4, so y is equal to 5. And for this one, I get y equals 3 minus 4, so y is equal to negative 1. So for this one, I have 2 solutions. I have a point at 3, 5, And I have another intersection point at 1, -1. So that is a conic. There was only one squared term, so more than likely it's a parabola. So a parabola intersecting a line. All right, next example. Obviously, we have two different types of conic sections. Looks to me like probably two parabolas since there's only one squared term. Okay, so for this one, we're going to use elimination. And you just have to decide by looking to see which one is going to be the easiest to eliminate. So I can see right here, if I multiply this by 2, I can eliminate my y squared terms. You don't necessarily have to eliminate those first. You could eliminate just a single variable if you wanted to. It's all going to work out the same in the end, but you're going to have to factor at some point. All right, so if I multiply that first one by 2, I get -2y squared plus x plus 2x minus 22y minus 60 equals 0. And if I go ahead and add these two together, I can save myself a step. So I get 0 there, I get 3x, my y's cancel, my constants cancel, so I get 3x equals 0. So I get one value of x, x is equal to 0. Okay, so now I have to go back and pick an equation to substitute in 0 for x. So again, it really doesn't matter, but I'm going to have to use the quadratic formula, or I'm going to have to solve a quadratic. So I'm going to choose this one just because my y squared is positive. So if I substitute x here, I get 2y squared. That's a 0, so plus 22y plus 60 equals 0. And now I'm factoring. So greatest common factor is 2. Always look for a greatest common factor first. So now I have a quadratic to solve. So I get 2 multiply to 30 and add to 11. So that's going to be 6 and 5. So here I get y equals -6 and y equals -5. So I have two solutions. I have 0, -6 and 0, -5. So pretty much two parabolas intersecting at 2 points. Okay, so if you would have gone and decided to eliminate the x term at the beginning, then you would have been solving a quadratic. You would have got these two solutions first. And then when you plug them back in, you're going to get x equals 0 for both of those values. All right, so as always, they start looking a little more complicated, but if you look close, they're really not. So I can see that if I add these two together, my x's go, my x squareds go away, and my single variable x goes away, and all I'm left with is y's. So if I add, I get 3y squared plus 24y plus 21 equals 0. Again, greatest common factor makes this easier to factor. So pull out a 3. So factor your quadratic, y plus 7, y plus 1. So I have y is equal to 7 and y is equal to negative 1. So now I need to go back and pick which beginning equation I want to use. And since I'm plugging in y and solving for x, I'm going to choose this first one because my x squared is positive and a little bit easier to work with. All right, so I am plugging in 7 here, and I am plugging 7 in here. So I get x squared plus 2 times 7 squared is 49, plus 12x plus 16 times 7, that's a plus 50, equals 0. So x squared plus 98 plus 12x plus, actually that, all right, so this 7 right here should be a negative 7. Sorry about that. So then this is going to make this a negative 7. My positive 49 is still correct. So this is going to be a minus 112 plus, and that should have been a 50. 50 equals 0. So I have x squared plus 12x. Oh, this is 148. 98 and 50 is 148. Minus 112 is 36. And again, I factor. So this is a perfect square trinomial, x plus 6 squared. So x equals negative 6. So I have a point at negative 6, negative 7. And over here, I basically have to do the same thing with the negative 1. So I am going to run out of room. So I have x squared, I'll have to write small, plus 2 times negative 1 squared, which is q, plus 12x. So now I'm here. So I have 16 times negative 1, which is minus 16, plus 50 equals 0. So put my constants together. I have x squared plus 12x. Let's see, negative 2, negative 14. So again, I have plus 36 equals 0. And if you look off over here, I basically have the exact same quadratic. So over here, I'm going to get x equals negative 6 as well. So my point of solution on this side is negative 1, negative 6 for my x, negative 1 for my y. Okay, so with x being negative 6, those two conic sections would be intersecting on a vertical line since your x value is constant there. All right, one more. Okay, so same idea here. Inspect it first. And I can see if I multiply this one by a negative 1, then my y terms are all going to cancel. So this is going to become a negative. This is going to become a negative. This will become a positive. This will become subtraction. This will become subtraction. So save myself some writing time there. All right, so I have -1 plus 8, which is 7x squared. My y's squareds go away. I have -4 or a +4 minus 32, which is minus 28x. My y terms go away. And I have -58 plus 23, which is -35. So I'm left with a quadratic in terms of x. There's that GCF again of 7. Factor the quadratic, multiply to -5, add to -4, so x minus 5 x plus 1 equals 0. So here I get two solutions, x equals 5, x equals -1. Okay, so I need to solve for the y values now. So I'm going to erase this where I covered over that problem. So now I need to determine which equation am I going to plug into, and keep in mind you're plugging in for x. So I'm going to choose this one, because then I don't have to deal with the 8 in front of x squared. This makes it a little bit simpler. All right, so if I plug into the first one, x squared, that'd be 5 squared, which is 25, plus y squared. -4 times 5 is minus 20, plus 16y, plus 58 equals 0. So I have y squared plus 16y. 25 minus 20 is 4, or 5. So plus 58 is going to be 63. So multiply to 63, add to 16, a 9 and a 7. So here I get y equals -9 and y equals -7. So for this one, I get two solutions just for this side. I get 5, -9, and 5, -7. For this one, I'm either going to have, I guess I could have 2 points of intersection if the other side doesn't work. More than likely, I'm going to have 3 or 4 total. All right, so I'm going to go back to this first equation, and I'm going to plug in -1. So -1 squared is 1. Y squared. -4 times -1 is plus 4. So over here, I get 4 plus 1 is 5. So 58 plus 5 is 63. So again, these are the same. Doesn't always happen, but in this case it did. So I'm going to get the exact same solutions over here. Y equals -9 and y equals -7. Only difference is your x value is different. So -1, -9, and -1, -7. Right, so this one would have 4 points of intersection, depending on what those conics were. All right, so you don't have an assignment today. You didn't have one yesterday. Tomorrow will just be another set of notes over graphing inequalities, looking for solution set intersections. And Friday, I am giving you just the day to work on a worksheet with 5 short problems. So those of you that are behind, I have set this week aside basically for you, so you can get yourselves caught up. So you guys have a great day. I'm sure you look forward to hearing from me tomorrow.